Here's an example where you're asked to find all the missing parts of a triangle where you're given the three sides. So the first thing to do would be to draw, okay, here we go. To draw a triangle. It doesn't need to be perfect. One thing you might note though, the longest side is C here, and so the longest side will always be opposite of the largest angle. And that might come into play in a second. So just note that C is the longest, little c is the longest side, and so angle C is going to be the largest angle. And then the other two I'll just label A and B here. So side A would be over here across from angle A, 15 centimeters, and side B would be across from angle B, 18 centimeters. Okay, so I always prefer to use law of sines if I can. But to use law of sines, you need one complete set with information that you know. So you need an angle and the corresponding side for one of these angles. And since we don't know the values of any of the angles, we can't use law of sines. We don't have a complete set, an angle and a corresponding side, which means we're going to have to use law of cosines. I prefer law of sines just because it's a simpler equation, which makes it easier to solve. But law of cosines will work, certainly. It's always best to solve for the largest angle first to avoid ambiguous scenarios, you know, like you had in some of those previous examples where C could be 59 degrees, it could be in quadrant 1 or quadrant 2. So I'm going to solve for angle C first, so that means I want to use this version of the law of cosines where it's equal to C squared equals A squared plus B squared minus 2AB cosine of angle C. So we're going to use this equation to find angle C. Before I plug in, I would probably rearrange this a bit. So I would go ahead and isolate cosine of C by subtracting A squared and B squared from both sides, so moving these guys over. So this would be equal then to negative 2AB cosine of C. And then divide both sides by the negative 2AB. And then one other quick thing, to avoid all the negatives in that equation, I would probably multiply the entire numerator and the entire denominator by negative 1. If I distribute the negative to all three parts over here, sorry, it's gotten a bit messy there, then the A squared will turn positive, the B squared will turn positive, the C squared will now be negative, and then instead of negative 2AB on the bottom, you have positive 2AB. So all of this is equal to, well, I guess I should write it over here, keep things lined up, to cosine of C. If you plug in what you know, so I'm going to write that over here, for these quantities A, B, and C, so you're going to have, what, 15 squared plus 18 squared for B minus C squared, so that's 29 over 2 times A times B. Okay, so if you type that into your calculator, you're going to get negative 292 in the numerator over 540. So that's just a matter of taking all of this and typing it into the calculator. Equals cosine of C. So to solve for angle C, we would want to take inverse cosine of both sides to isolate the angle C here. So take inverse cosine of this, and that I'll have to write on a new page. So if you do inverse cosine, this is C equals inverse cosine of negative 292 over 540. Okay, you get about 122.7 degrees. Okay, and so that's in quadrant 2. There's no way we have another solution, I mean, if we're looking for another angle where cosine has this negative value, that would be in quadrant 3, which means it would be more than 180 degrees if it's in quadrant 3. So that's not possible for an angle inside a triangle, since the sum of all the angles is 180. Okay, so we have C. We know now that C up here is equal to 122.7 degrees. Now we need to find angle A and angle B. If we find one of those, then the third one's easy. You just do 180 minus the two angles that you know. Now to find one of them, and I guess I'll go for the next biggest, so I'll go for angle B next. Notice that now we can use law of sines because we have angle C and side C. As soon as you have a complete pair like that, you can use law of sines. With law of sines, it's best to put whatever you're solving for on top. So since we're solving for the angle B, I would put sine of B on top over side B, which is 18 centimeters. And then sine of C, so 122.7 degrees, over side C, which is 29 centimeters. Just put a little C equals down here just to keep track. So to isolate sine of B, I would multiply both sides by 18. That would cancel there. Okay, so now to type this into your calculator. Most likely it's going to look like this. Sine, and then if you have a TI-83, or I believe a TI-84, and that's, I know what most students usually have, when you press sine, it automatically opens a parenthesis. So if that's the case, I know I said this in a few videos, be sure and close it after you type in 122.7 times 18 and then divided by 29. And that will give you about, let's see if I wrote it down, yes, 0.5223. So keep in mind, right, this is equal to sine of B. So to find the actual angle B, to inverse sine to both sides, take inverse sine of that, and there you get about 31.5 degrees. And notice that's the only possibility, because if you think about, okay, sine, we're looking for where sine is about 0.5. So that's going to happen twice. It'll happen in quadrant 1, it'll happen in quadrant 2. We just found this angle to be 31.5 degrees. If we wanted to consider the quadrant 2 solution, so this angle right here, that would be, I'm sorry, I'm writing in the corner here, 180 minus the 31.5. So what's that? I mean, it's a little less than 150, but keep in mind that this is already 122, and the sum of the angles is supposed to be 180. So there's no way, I mean, this angle over here that's about 150 is going to fit in that triangle. So this is the only solution. This is not one of those two solution kind of triangles. So this angle is 31.5 degrees. And then to find angle A, you would just do 180 minus the two angles that we know now, 122.7, 31.5, to find that third angle, which is 25.8. And that would go over here. And now we know all three angles and all three sides for this triangle.